Chapter 6, Part 3 of An Inquiry into the Human Mind on the Principles of Common Sense. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Stephen Reynolds. An Inquiry into the Human Mind on the Principles of Common Sense by Thomas Reid. Chapter 6, Part 3. Section 11. Of our seeing objects erect by inverted images. Another phenomenon which hath perplexed philosophers is our seeing objects erect when it is well known that their images or pictures upon the tunica retina of the eye are inverted. The sagacious Kepler first made the noble discovery that distinct but inverted pictures of visible objects are formed upon the retina by the rays of light coming from the object. The same great philosopher demonstrated from the principles of optics how these pictures are formed, to wit, that the rays coming from any one point of the object, and falling upon the various parts of the pupil, are by the cornea and crystalline refracted so as to meet again in one point of the retina, and there paint the colour of that point of the object from which they come. As the rays from different points of the object cross each other before they come to the retina, the picture they form must be inverted, the upper part of the object being painted upon the lower part of the retina, the right side of the object upon the left of the retina, and so of the other parts. This philosopher thought that we see objects erect by means of these inverted pictures, for this reason, that as the rays from different points of the object cross each other before they fall upon the retina, we conclude that the impulse which we feel upon the lower part of the retina comes from above, and that the impulse which we feel upon the higher part comes from below. Descartes afterwards gave the same solution of this phenomena, and illustrated it by the judgment which we form of the position of objects which we feel with our arms crossed, or with two sticks that cross each other. But we cannot acquiesce in this solution. First, because it supposes our seeing things erect to be a deduction of reason drawn from certain premises, whereas it seems to be an immediate perception. And secondly, because the premises from which all mankind are supposed to draw this conclusion never entered into the minds of the far greater part, but are absolutely unknown to them. We have no feeling of perception of the pictures upon the retina, and as little surely of the position of them. In order to see objects erect, according to the principles of Kepler or Descartes, we must previously know that the rays of light come from the object to the eye in straight lines. We must know that the rays from different points of the object cross one another before they form the picture upon the retina. And lastly, we must know that these pictures are really inverted. Now, although all these things are true, and known to philosophers, yet they are absolutely unknown to the far greatest part of mankind. Nor is it possible that they who are absolutely ignorant of them should reason from them, and build conclusions upon them. Since therefore visible objects appear erect to the ignorant as well as to the learned, this cannot be a conclusion drawn from premises which never entered into the minds of the ignorant. We have indeed had occasion to observe many instances of conclusions drawn either by means of original principle, or by habit from premises which pass through the mind very quickly, and which are never made the objects of reflection. But surely no man will conceive it possible to draw conclusions from premises which never entered into the mind at all. Bishop Berkeley, having justly rejected this solution, gives one founded upon his own principles, wherein he is followed by the judicious Dr. Smith in his Optics, and this we shall next explain and examine. That ingenious writer conceives the ideas of sight to be altogether unlike those of touch, and since the notions we have of an object by these different senses have no similitude, we can learn only by experience how one sense will be affected by what, in a certain manner, affects the other. Figure, position, and even number in tangible objects are ideas of touch, and although there is no similitude between these and the ideas of sight, yet we learn by experience that a triangle affects the sight in such a manner, and that a square affects it in such another manner. Hence we judge that which affects it in the first manner to be a triangle, and that which affects it in the second to be a square. In the same way, finding from experience that an object in an erect position affects the eye in one manner, and the same object in an inverted position affects it in another, we learn to judge by the manner in which the eye is affected, whether the object is erect or inverted. In a word, visible ideas, according to this author, are signs of the tangible, and the mind passeth from the sign to the thing signified, not by means of any similitude between the one and the other, nor by any natural principle, but by having found them constantly conjoined in experience, as the sounds of a language are with the things they signify. So that if the images upon the retina had been always erect, they would have shewn the objects erect, in the manner as they do now that they are inverted. Nay, if the visible idea which we now have from an inverted object had been associated from the beginning with the erect position of that object, it would have signified an erect position, as readily as it now signifies an inverted one. And if the visible appearance of 2 shillings had been found connected from the beginning with the tangible idea of 1 shilling, that appearance would as naturally and readily have signified the unity of the object as now it signifies its duplicity. This opinion is undoubtedly very ingenious, and if it is just, serves to resolve not only the phenomenon now under consideration, but likewise that which we shall next consider, our seeing objects single with 2 eyes. It is evident that in this solution it is supposed that we do not originally, and previous to acquired habits, see things either erect or inverted, of one figure or another, single or double, but learn from experience to judge of their tangible position, figure, and number by certain visible signs. Indeed, it must be acknowledged to be extremely difficult to distinguish the immediate and natural objects of sight from the conclusions which we have been accustomed from infancy to draw from them. Bishop Berkeley was the first that attempted to distinguish the one from the other, and to trace out the boundary that divides them. And if in doing so he hath gone a little to the right hand or to the left, this might be expected in a subject altogether new and of the greatest subtlety. The nature of vision hath received great light from this distinction, and many phenomena in optics, which before appeared altogether unaccountable, have been clearly and distinctly resolved by it. It is natural and almost unavoidable to one who hath made an important discovery in philosophy to carry it a little beyond its sphere, and to apply it to the resolution of phenomena which do not fall within its province. Even the great Newton, when he had discovered the universal law of gravitation, and observed how many of the phenomena of nature depend upon this, and other laws of attraction and repulsion, could not help expressing his conjecture that all the phenomena of the material world depending upon attracting and repelling forces in the particles of matter. And I suspect that the ingenious Bishop of Cloyne, having found so many phenomena of vision reducible to the constant association of the ideas of sight and touch, carried this principle a little beyond its just limits. In order to judge as well as we can whether it is so, let us suppose such a blind man as Dr. Saunderson, having all the knowledge and abilities which a blind man may have, suddenly made to see perfectly. Let us suppose him kept from all opportunities of associating his ideas of sight with those of touch, until the former become a little familiar, and the first surprise occasioned by objects so new being abated, he has time to canvass them, and to compare them in his mind with the notions which he formerly had by touch, and in particular to compare in his mind that visible extension which his eyes present with the extension in length and breadth with which he was before acquainted. We have endeavoured to prove that a blind man may form a notion of the visible extension and figure of bodies from the relation which it bears to their tangible extension and figure. Much more, when this visible extension and figure are presented to his eye, will he be able to compare them with tangible extension and figure, and to perceive that the one has length and breadth as well as the other, that the one may be bounded by lines, either straight or curve, as well as the other. And therefore he will perceive that there may be visible as well as tangible circles, triangles, quadrilateral and multilateral figures. And although the visible figure is coloured and the tangible is not, they may notwithstanding have the same figure, as two objects of touch may have the same figure, although one is hot and the other cold. We have demonstrated that the properties of visible figures differ from those of the plane figures which they represent, but it was observed at the same time that when the object is so small as to be seen distinctly at one view, and is placed directly before the eye, the difference between the visible and the tangible figure is too small to be perceived by the senses. Thus it is true that of every visible triangle the 3 angles are greater than 2 right angles, whereas in a plane triangle the 3 angles are equal to 2 right angles. But when the visible triangle is small, its 3 edges will be so nearly equal to 2 right angles that the sense cannot discern the difference. In like manner, the circumferences of unequal visible circles are not, but those of plane circles are, in the ratio of their diameters, yet in small visible circles the circumferences are very nearly in the ratio of their diameters, and the diameter bears the same ratio to the circumference as in a plane circle, very nearly. Hence it appears that small visible figures, and such only can be seen distinctly at one view, have not only a resemblance to the plain tangible figures which have the same name, but are to all sense the same. So that if Dr. Saunderson had been made to see, and had attentively viewed the figures of the first book of Euclid, he might by thought and consideration, without touching them, have found out that they were the very figures he was before so well acquainted with by touch. When plane figures are seen obliquely, their visible figure differs more from the tangible, and the representation which is made to the eye of solid figures is still more imperfect, because visible extension hath not 3 but 2 dimensions only. Yet as it cannot be said that an exact picture of a man hath no resemblance to the man, or that a perspective view of a house hath no resemblance of the house, so it cannot be said with any propriety that the visible figure of a man or of a house hath no resemblances of the objects which they represent. Bishop Berkeley therefore proceeds upon a capital mistake, in supposing that there is no resemblance betwixt the extension, figure, and position which we see, and that which we perceive by touch. We may further observe that Bishop Berkeley's system with regard to material things must have made him see this question of the erect appearance of objects in a very different light from that in which it appears to those who do not adopt his system. In his theory of vision he seems indeed to allow that there is an external material world, but he believed that this external world is tangible only, and not visible, and that the visible world, the proper object of sight, is not external but in the mind. If this is supposed, he that affirms that he sees things erect and not inverted, affirms that there is a top and a bottom, a right and a left in the mind. Now I confess I am not so well acquainted with the topography of the mind as to be able to affix a meaning to these words when applied to it. We shall therefore allow that if visible objects were not external, but existed only in the mind, they could have no figure or position, or extension, and that it would be absurd to affirm that they are seen either erect or inverted, or that there is any resemblance between them and the objects of touch. But when we propose the question why objects are seen erect and not inverted, we take it for granted that we are not in Bishop Berkeley's ideal world, but in that world which men, who yield to the dictates of common sense, believe themselves to inhabit. We take it for granted that the objects both of sight and touch are external, and have a certain figure and a certain position with regard to one another and with regard to our bodies, whether we perceive it or not. When I hold my walking cane upright in my hand and look at it, I take it for granted that I see and handle the same individual object. When I say that I feel it erect, my meaning is that I feel the head directed from the horizon, and the point directed towards it. And when I say that I see it erect, I mean that I see it with the head directed from the horizon and the point towards it. I conceive the horizon as a fixed object, both of sight and touch, with relation to which objects are said to be high or low, erect or inverted. And when the question is asked why I see the object erect and not inverted, it is the same as if you should ask why I see it in that position which it really hath, or why the eye shows the real position of objects, and doth not show them in an inverted position, as they are seen by a common astronomical telescope, or as their pictures are seen upon the retina of an eye when it is dissected. Section 12. The same subject continued. It is impossible to give a satisfactory answer to this question, otherwise than by pointing out the laws of nature which take place in vision, for by these the phenomena of vision must be regulated. Therefore I answer, first, that by a law of nature the rays of light proceed from every point of the object to the pupil of the eye in straight lines. Secondly, that by the laws of nature the rays coming from any one point of the object to the various parts of the pupil are so refracted as to meet again in one point of the retina, and the rays from different points of the object first crossing each other and then proceeding to as many different points of the retina, form an inverted picture of the object. So far the principles of optics carry us, and experience further assures us, that if there is no such picture upon the retina, there is no vision, and that such as the picture on the retina is, such is the appearance of the object in colour and figure, distinctness or indistinctness, brightness or faintness. It is evident, therefore, that the pictures upon the retina are, by the laws of nature, a mean of vision, but in what way they accomplish their end we are totally ignorant. Philosophers conceive that the impression made upon the retina by the rays of light is communicated to the optic nerve, and by the optic nerve conveyed to some part of the brain, by them called the sensorium, and that the impression thus conveyed to the sensorium is immediately perceived by the mind which is supposed to reside there. But we know nothing of the seat of the soul, and we are so far from perceiving immediately what is transacted in the brain, that of all parts of the human body we know least about it. It is indeed very probable that the optic nerve is an instrument of vision no less necessary than the retina, and that some impression is made upon it by means of the picture on the retina, but of what kind this impression is we know nothing. There is not the least probability that there is any picture or image of the object either in the optic nerve or brain. The pictures on the retina are formed by the rays of light, and whether we suppose with some that their impulse upon the retina causes some vibration of the fibres of the optic nerve, or with others that it gives motion to some subtle fluid contained in the nerve, neither that vibration nor this motion can resemble the visible object which is presented to the mind. Nor is there any probability that the mind perceives the pictures upon the retina. These pictures are no more objects of our perception than the brain is, or the optic nerve. No man ever saw the pictures in his own eye, nor indeed the pictures in the eye of another, until it was taken out of the head and duly prepared. It is very strange that philosophers of all ages should have agreed in this notion, that the images of external objects are conveyed by the organs of sense to the brain and are there perceived by the mind. Nothing can be more unphilosophical. For first, this notion hath no foundation in fact and observation. Of all the organs of sense, the eye only, as far as we can discover, forms any kind of image of its object, and the images formed by the eye are not in the brain, but only in the bottom of the eye, nor are they at all perceived or felt by the mind. Secondly, it is as difficult to conceive how the mind perceives images on the brain, as how it perceives things more distant. If any man will show how the mind may perceive images in the brain, I will undertake to show how it may perceive the most distant objects. For if we give eyes to the mind, to perceive what has transacted at home in its dark chamber, why may we not make these eyes a little longer sighted? And then we shall have no occasion for that unphilosophical fiction of images in the brain. In a word, the manner and mechanism of the mind's perception is quite beyond our comprehension, and this way of explaining it by images in the brain seems to be founded upon very gross notions of the mind and its operation, as if the supposed images in the brain by a kind of contact formed similar impressions or images of objects upon the mind, of which impressions it is supposed to be conscious. We have endeavoured to show throughout the course of this inquiry that the impressions made upon the mind by means of the five senses have not the least resemblance to the objects of sense, and therefore, as we see no shadow of evidence that there are any such images in the brain, so we see no purpose, in philosophy, that the supposition of them can answer. Since the picture upon the retina, therefore, is neither itself seen by the mind, nor produces any impression upon the brain or sensorium, which is seen by the mind, nor makes any impression upon the mind that resembles the object, it may still be asked how this picture upon the retina causes vision. Before we answer this question, it is proper to observe that in the operations of the mind, as well as in those of bodies, we must often be satisfied with knowing that certain things are connected and invariably follow one another without being able to discover the chain that goes between them. It is to such connections that we give the name of laws of nature, and when we say that one thing produces another by a law of nature, this signifies no more but that the one thing, which we call in popular language the cause, is constantly and invariably followed by another, which we call the effect, and that we know not how they are connected. Thus we see it is a fact that bodies gravitate towards bodies, and that this gravitation is regulated by certain mathematical proportions, according to the distances of the bodies from each other, and their quantities of matter. Being unable to discover the cause of this gravitation, and presuming that it is the immediate operation either of the author of nature, or of some subordinate cause which we have not hitherto been able to reach, we call it a law of nature. If any philosopher should hereafter be so happy as to discover the cause of gravitation, this can only be done by discovering some more general law of nature, of which the gravitation of bodies is a necessary consequence. In every chain of natural causes, the highest link is a primary law of nature, and the highest link which we can trace by just induction is either this primary law of nature or a necessary consequence of it. To trace out the laws of nature by induction from the phenomena of nature is all that true philosophy aims at, and all that it can ever reach. There are laws of nature by which the operations of the mind are regulated. There are also laws of nature that govern the material system, and as the latter are the ultimate conclusions which the human faculties can reach in the philosophy of bodies, so the former are the ultimate conclusions we can reach in the philosophy of minds. To return, therefore, to the question above proposed, we may see, from what hath been just now observed, that it amounts to this: by what law of nature is a picture upon the retina the mean or occasion of my seeing an external object of the same figure and colour, in a contrary position and in a certain direction from the eye? It will without doubt be allowed that I see the whole object in the same manner, and by the same law by which I see any one point of it. Now I know it to be a fact that in direct vision I see every point of the object in the direction of the right line that passeth from the centre of the eye to that point of the object. And I know likewise from optics that the ray of light that comes to the centre of my eye passes on to the retina in the same direction. Hence it appears to be a fact that every point of the object is seen in the direction of a right line passing from the picture of that point on the retina through the centre of the eye. As this is a fact that holds universally and invariably, it must either be a law of nature or the necessary consequence of some more general law of nature. And according to the just rules of philosophizing, we may hold it for a law of nature until some more general law be discovered, whereof it is a necessary consequence, which I suspect can never be done. Thus we see that the phenomena of vision lead us by the hand to a law of nature, or a law of our constitution, of which law our seeing objects erect by inverted images is a necessary consequence. For it necessarily follows from the law we have mentioned that the object whose picture is lowest on the retina must be seen in the highest direction from the eye, and that the object whose picture is on the right of the retina must be seen on the left, so that if the pictures had been erect in the retina we should have seen the object inverted. My chief intention in handling this question was to point out this law of nature, which, as it is a part of the constitution of the human mind, belongs properly to the subject of this inquiry. For this reason I shall make some further remarks upon it, after doing justice to the ingenious Dr. Portersfield, who long ago in the Medical Essays, or more lately in his Treatise of the Eye, pointed out as a primary law of our nature that a visible object appears in the direction of a right line perpendicular to the retina at that point where its image is painted. If lines drawn from the centre of the eye to all parts of the retina be perpendicular to it, as they must be very nearly, this coincides with the law we have mentioned, and is the same in other words. In order, therefore, that we may have a more distinct notion of this law of our constitution, we may observe: 1. That we can give no reason why the retina is, of all parts of the body, the only one on which pictures made by the rays of light cause vision, and therefore we must resolve this solely into a law of our constitution. We may form such pictures by means of optical glasses upon the hand, or upon any other part of the body, but they are not felt, nor do they produce anything like vision. A picture upon the retina is as little felt as one upon the hand, but it produces vision, for no other reason that we know, but because it is destined by the wisdom of nature to this purpose. The vibrations of the air strike upon the eye, the palate, and the olfactory membrane, with the same force as upon the membrana tympani of the ear. The impression they make upon the last produces the sensation of sound, but their impression upon any of the former produce no sensation at all. This may be extended to all of the senses, whereof each hath its peculiar law, according to which the impressions made upon the organ of that sense produce sensations or perceptions in the mind that cannot be produced by impressions made upon any other organ. 2. We may observe that the law of perception by the different senses are very different, not only in respect of the nature of the objects perceived by them, but likewise in respect of the notices they give us of the distance and situation of the object. In all of them the object is conceived to be external, and to have real existence, independent of our perception. But in one, the distance, figure, and situation of the object are all presented to the mind. In another, the figure and situation, but not the distance. And in others, neither figure, situations, nor distance. In vain do we attempt to account for these varieties in the manner of perception by the different senses, from principles of anatomy or natural philosophy. They must at last be resolved into the will of our Maker, who intended that our powers of perception should have certain limits, and adapted the organs of perception and the laws of nature by which they operate to his wise purpose. When we hear an unusual sound, the sensation indeed is in the mind, but we know that there is something external that produced this sound. At the same time, our hearing does not inform us whether the sounding body is near or at a distance, in this direction or that, and therefore we look round to discover it. If any new phenomenon appears in the heavens, we see exactly its colour, its apparent place, magnitude, and figure, but we see not its distance. It may be in the atmosphere, it may be among the planets, or it may be in the sphere of the fixed stars, for anything the eye can determine. The testimony of the senses of touch reaches only to objects that are contiguous to the organ, but with regard to them is more precise and determinate. When we feel a body with our hand, we know the figure, distance, and position of it, as well as whether it is rough or smooth, hard or soft, hot or cold. The sensations of touch, of seeing, and hearing are all in the mind and can have no existence but when they are perceived. How do they all constantly and invariably suggest the conception and belief of external objects, which exist whether they are perceived or not? No philosopher can give any other answer to this but that such is the constitution of our nature. How do we know that the object of touch is at the finger's end and nowhere else? That the object of sight is in such a direction from the eye, and in no other, but may be at any distance? And that the object of hearing may be at any distance and in any direction? Not by custom, surely, not by reasoning or comparing ideas, but by the constitution of our nature. How do we perceive visible objects in the direction of right lines, perpendicular to that part of the retina on which the rays strike, while we do not perceive the object of hearing in lines perpendicular to the membrana tympani, upon which the vibrations of the air strike? Because such are the laws of nature. But do we know the parts of our bodies affected by particular pains, not by experience or by reasoning, but by the constitution of nature? The sensation of pain is no doubt in the mind, and cannot be said to have any relation from its own nature to any part of the body. But this sensation by our constitution gives a perception of some particular part of the body, whose disorder causes the uneasy sensation. If it were not so, a man who never before felt either the gout or the toothache, when he is first seized with the gout in his toe, might mistake it for a toothache. Every sense, therefore, hath its peculiar laws and limits by the constitution of our nature. And one of the laws of sight is that we always see an object in the direction of a right line passing from its image on the retina through the centre of the eye. 3. Perhaps some readers will imagine that it is easier, and will answer the purpose as well, to conceive a law of nature by which we shall always see objects in the place in which they are, and in their true position, without having recourse to images on the retina or to the optical centre of the eye. To this I answer that nothing can be a law of nature which is contrary to fact. The laws of nature are the most general facts we can discover in the operations of nature. Like other facts, they are not to be hit upon by a happy conjecture, but justly deduced from observation. Like other general facts, they are not to be drawn from a few particulars, but from a copious, patient, and cautious induction. That we see things always in their true place and position is not fact, and therefore it can be no law of nature. In a plain mirror I see myself and other things in places very different from those they really occupy, and so it happens in every instance wherein the rays coming from the objects are either reflected or refracted before falling upon the eye. Those who know anything of optics know that in all such cases the object is seen in the direction of a line passing from the centre of the eye to the point where the rays were last reflected or refracted, and that upon this all the powers of the telescope and microscope depend. Shall we say then that it is a law of nature that the object is seen in the direction which the rays have when they fall on the eye, or rather in the direction contrary to that of the rays when they fall upon the eye? No, this is not true, and therefore it is no law of nature. For the rays from any one point of the object come to all parts of the pupil, and therefore must have different directions. But we see the object only in one of these directions, to wit, in the direction of the rays that came to the centre of the eye. And this holds true even when the rays that should pass through the centre are stopped, and the object is seen by rays that pass at a distance from the centre. Perhaps it is still to be imagined that although we are not made so as to see objects always in their true place, nor so as to see them precisely in the direction of the rays when they fall upon the cornea, yet we may be so made as to see the object in the direction which the rays have when they fall upon the retina, after they have undergone all their refractions in the eye, that is, in the direction in which the rays pass from the crystalline to the retina. But neither is this true, and consequently it is no law of our constitution. In order to see that it is not true, we must conceive all the rays that pass from the crystalline to one point of the retina as forming a small cone, whose base is upon the back of the crystalline, and whose vertex is a point of the retina. It is evident that the rays which form the picture in this point have various directions, even after they pass the crystalline. Yet the object is seen only in one of these directions, to wit, in the direction of the rays that come from the centre of the eye. Nor is this owing to any particular virtue in the central rays, or in the centre itself, for the central rays may be stopped. When they are stopped, the image will be formed upon the same point of the retina as before, by rays that are not central, nor have the same direction which the central rays had, and in this case the object is seen in the same direction as before, although there are now no rays coming in that direction. From this induction we conclude that our seeing an object in that particular direction in which we do see it, is not owing to any law of nature by which we are made to see it in the direction of the rays, either before their refractions in the eye, or after, but to a law of our nature by which we see the object in the direction of the right line that passeth from the picture of the object upon the retina to the centre of the eye. The facts upon which I ground this induction are taken from some curious experiments of Scheiner in his Fundament Optik, quoted by Dr. Porterfield, and confirmed by his experience. I have also repeated these experiments, and found them to answer. As they are easily made, and tend to illustrate and confirm the law of nature I have mentioned, I shall recite them as briefly and distinctly as I can. Experiment 1. Let a very small object, such as the head of a pin, well illuminated, be fixed at such a distance from the eye as to be beyond the nearest limit, and within the farthest limit of distinct vision. For a young eye, not near-sighted, the object may be placed at the distance of 18 inches. Let the eye be kept steadily in one place, and take a distinct view of the object. We know from the principles of optics that the rays from any one point of this object, whether they pass through the centre of the eye, or at any distance from the centre which the breadth of the pupil will permit, do all unite again in one point of the retina. We know also that these rays have different directions, both before they fall upon the eye, and after they pass through the crystalline. Now we can see the object by any one small parcel of these rays, excluding the rest, by looking through a small pinhole in a card. Moving this pinhole over the various parts of the pupil, we can see the object, first by the rays that pass above the centre of the eye, then by the central rays, then by the rays that pass below the centre, and in like manner by the rays that pass on the right and left of the centre. Thus we view this object successively by rays that are central, and by rays that are not central, by rays that have different directions, and are variously inclined to each other, both when they fall upon the cornea and when they fall upon the retina, but always by rays which fall upon the same point of the retina. And what is the event? It is this, that the object is seen in the same individual direction, whether seen by all these rays together, or by any one parcel of them. Experiment 2. Let the object above mentioned be now placed within the nearest limit of distinct vision, that is, for an eye that is not near-sighted, at the distance of 4 or 5 inches. We know that in this case the rays coming from one point of the object do not meet in one point of the retina, but spread over a small circular spot of it, the central rays occupying the centre of this circle, the rays that pass above the centre occupying the upper part of the circular spot, and so of the rest. And we know that the object is in this case seen confused, every point of it being seen, not in one but in various directions. To remedy this confusion, we look at the object through the pinhole, and while we move the pinhole over the various parts of the pupil, the object does not keep its place, but seems to move in a contrary direction. It is here to be observed that when the pinhole is carried upwards over the pupil, the picture of the object is carried upwards upon the retina, and the object at the same time seems to move downwards, so as to be always in the right line passing from the picture through the centre of the eye. It is likewise to be observed that the rays which form the upper and lower pictures upon the retina do not cross each other as in ordinary vision, yet still the higher picture shews the object lower, and the lower picture shews the object higher, in the same manner as when the rays cross each other. Whence we may observe, by the way, that this phenomenon of our seeing objects in a position contrary to that of their pictures upon the retina does not depend upon the crossing of the rays, as Kepler and Descartes conceived. Experiment 3. Other things remaining as in the last experiment, make 3 pinholes in a straight line so near that the rays coming from the object through all the holes may enter the pupil at the same time. In this case we have a very curious phenomenon, for the object is seen triple with one eye, and if you make more holes within the breadth of the pupil, you will see as many objects as there are holes. However, we shall suppose them only 3, one on the right, one in the middle, and one on the left, in which case you see 3 objects standing in a line from right to left. It is here to be observed that there are 3 pictures on the retina, that on the left being formed by the rays which pass on the left of the eye's centre, the middle picture being formed by the central rays, and the right-hand picture by the rays which pass on the right of the eye's centre. It is farther to be observed that the object which appears on the right is not that which is seen through the hole on the right, but that which is seen through the hole on the left, and in like manner the left-hand object is seen through the hole on the right, as is easily proved by covering the holes successively. So that whatever is the direction of the rays which form the right-hand and left-hand pictures, still the right-hand picture shews a left-hand object, and the left-hand picture shows a right-hand object. Experiment 4. It is easy to see how the 2 last experiments may be varied by placing the object beyond the farthest limit of distinct vision. In order to make this experiment, I looked at a candle at the distance of 10 feet, and put the eye of my spectacles behind the card, that the rays from the same point of the object might meet and cross each other before they reached the retina. In this case, as in the former, the candle was seen in triple through the 3 pinholes, but the candle on the right was seen through the hole on the right, and, on the contrary, the left-hand candle was seen through the hole on the left. In this experiment, it is evident from the principles of optics that the rays forming the several pictures on the retina cross each other a little before they reach the retina, and therefore the left-hand picture is formed by the rays which pass through the hole on the right, so that the position of the pictures is contrary to that of the holes by which they are formed, and therefore it is also contrary to that of their objects, as we have found it to be in the former experiments. These experiments exhibit several uncommon phenomena that regard the apparent place and the direction of visible objects from the eye. phenomena that seem to be most contrary to the common rules of vision. When we look at the same time through three holes that are in a right line, and at certain distances from each other, we expect that the objects seen through them should really be, and should appear to be, at a distance from each other. Yet by the first experiment we may through three such holes see the same object and the same point of that object, and through all the three it appears in the same individual place and direction. When the rays of light come from the object in right lines to the eye, without any reflection, inflection, or refraction, we expect that the object should appear in its real and proper direction from the eye, and so it commonly does. But in the second, third, and fourth experiments, we see the object in a direction which is not its true and real direction from the eye, although the rays come from the object to the eye without any inflection, reflection, or refraction. When both the object and the eye are fixed without the least motion, and the medium unchanged, we expect that the object should appear to rest and keep the same place. Yet in the second and fourth experiments, when both the eye and the object are at rest, and the medium unchanged, we make the object appear to move upwards or downwards, or in any direction we please. When we look at the same time, and with the same eye, through holes that stand in a line from right to left, we expect that the object seen through the left-hand hole should appear on the left, and the object seen through the right-hand hole should appear on the right. Yet in the third experiment we find the direct contrary. Although many instances occur in seeing the same object double with two eyes, we always expect that it should appear single when seen only by one eye. Yet in the second and fourth experiment we have instances wherein the same object may appear double, triple, or quadruple to one eye, without the help of a polyhedron or multiplying glass. All these extraordinary phenomena regarding the direction of visible objects from the eye, as well as those that are common and ordinary, lead us to the law of nature which I have mentioned, and are the necessary consequences of it. And as there is no probability that we shall ever be able to give a reason why pictures upon the retina make us see external objects, any more than pictures upon the hand or upon the cheek, or that we shall ever be able to give a reason why we see the object in the direction of a line passing from its picture through the centre of the eye, rather than in any other direction, I am therefore apt to look upon this law as a primary law of our constitution. To prevent being misunderstood, I beg the reader to observe that I do not mean to affirm that the picture upon the retina will make us see an object in the direction mentioned, or in any direction, unless the optic nerve, and the other more immediate instruments of vision, be sound and perform their function. We know not well what is the office of the optic nerve, nor in what manner it performs that office, but that it hath some part in the faculty of seeing seems to be certain, because in an amaurosis, which is believed to be a disorder of the optic nerve, the pictures of the retina are clear and distinct, and yet there is no vision. We know still less of the use and function of the choroid membranes, but it seems likewise to be necessary to vision, for it is well known that pictures upon that part of the retina, where it is not covered by the choroid, I mean at the entrance of the optic nerve, produce no vision, any more than a picture upon the hand. We acknowledge, therefore, that the retina is not the last and most immediate instrument of the mind in vision. There are other material organs whose operation is necessary to seeing, even after the pictures upon the retina are formed. If ever we come to know the structure and use of the choroid membrane, the optic nerve, and the brain, and what impressions are made upon them by means of the pictures on the retina, some more links in the chain may be brought within our view, and a more general law of vision discovered. But while we know so little of the nature and office of these more immediate instruments of vision, it seems to be impossible to trace its laws beyond the pictures upon the retina. Neither do I pretend to say that there may not be diseases of the eye, or accidents which may occasion our seeing objects in a direction somewhat different from that mentioned above. I shall beg leave to mention one instance of this kind that concerns myself. In May 1761, being occupied in making an exact meridian in order to observe the transit of Venus, I rashly directed to the sun by my right eye the cross hairs of a small telescope. I had often done the like in my younger days with impunity, but I suffered by it at last, which I mention as a warning to others. I soon observed a remarkable dimness in that eye, and for many weeks when I was in the dark or shut my eyes, there appeared before the right eye a lucid spot which trembled much like the image of the sun seen by reflection from water. This appearance grew fainter and less frequent by degrees, so that now there are seldom any remains of it. But some other very sensible effects of this hurt still remain. For, first, the sight of the right eye continues to be more dim than that of the left. Secondly, the nearest limit of distinct vision is more remote in the right eye than in the other, although before the time mentioned they were equal in both these respects, as I had found by many trials. But thirdly, what I chiefly intended to mention is that a straight line, in some circumstances, appears to the right eye to have a curvature in it. Thus, when I look upon a music book, and shutting my left eye direct the right to a point of the middle line of the 5 which compose the staff of music, the middle line appears dim, indeed at the point to which the eye is directed, but straight at the same time the 2 lines above it, and the 2 below it, appear to be bent outwards, and to be more distant from each other, and from the middle line, than at any other parts of the staff, to which the eye is not directed. Fourthly, although I have repeated this experiment times innumerable within these 16 months, I do not find that custom and experience takes away this appearance of curvature in straight lines. Lastly, this appearance of curvature is perceptible when I look with the right eye only, but not when I look with both eyes. Yet I see better with both eyes together than even with the left eye alone. I have related this fact minutely as it is, without regard to any hypothesis, because I think such uncommon facts deserve to be recorded. I shall leave it to others to conjecture the cause of this appearance. To me it seems most probable that a small part of the retina towards the centre is shrunk, and that thereby the contiguous parts are drawn nearer to the centre and to one another than they were before, and that objects whose images fall upon these parts appear at the distance from each other which corresponds not to the interval of the parts in their present preternatural contractions, but to their interval in their natural and sound state. Section 13. Of seeing objects single with 2 eyes. Another phenomenon of vision which deserves attention is our seeing objects single with 2 eyes. There are 2 pictures of the object, one on each retina, and each picture by itself makes us see an object in a certain direction from the eye. Yet both together commonly make us see only one object. All the accounts or solutions of this phenomenon given by anatomists and philosophers seem to be unsatisfactory. I shall pass over the opinions of Garin, of Gassendus, of Baptista, Porta, and Rohaut. The reader may see these examined and refuted by Dr. Porterfield. I shall examine Dr. Porterfield's own opinion, Bishop Berkeley's, and some others, but it will be necessary first to ascertain the facts, for if we mistake the phenomena of single and double vision, it is 10 to 1 but this mistake will lead us wrong in assigning the causes. This likewise we ought carefully to attend to, which is acknowledged in theory by all who have any true judgment or just taste in inquiries of this nature, but is very often overlooked in practice, namely, that in the solution of natural phenomena, all the length that the human faculties can carry us is only this, that from particular phenomena we may by induction trace out general phenomena, of which all the particular ones are necessary consequences. And when we have arrived at the most general phenomena we can reach, there we must stop. If it is asked why such a body gravitates towards the earth, all the answer that can be given is, because all bodies gravitate towards the earth. This is resolving a particular phenomenon into a general one. If it should again be asked, why do all bodies gravitate towards the earth, we can give no other solution of this phenomenon, but that all bodies whatsoever gravitate towards each other. This is resolving a general phenomenon into a more general one. If it should be asked why all bodies gravitate to one another, we cannot tell. But if we could tell, it could only be by resolving our universal gravitation of bodies into some other phenomenon still more general, and of which the gravitation of all bodies is a particular instance. The most general phenomena we can reach are what we call laws of nature, so that the laws of nature are nothing else but the most general facts relating to the operations of nature, which include a great many particular facts under them. And if in any case we should give the name of a law of nature to a general phenomenon, which human industry shall afterwards trace to one more general, there is no great harm done. The most general assumes the name of a law of nature when it is discovered, and the less general is contained and comprehended by it. Having premised these things, we proceed to consider the phenomena of single and double vision, in order to discover some general principle to which they all lead, and of which they are the necessary consequences. If we can discover any such general principle, it must either be a law of nature, or the necessary consequence of some law of nature, and its authority will be equal, whether it is the first or the last. 1. We find that when the eyes are sound and perfect, and the axis of both directed to one point, an object placed in that point is seen single. And here we observe that in this case the two pictures which show the object single are in the centres of the retina. When two pictures of a small object are formed upon points of the retina, if they show the object single, we shall for the sake of perspicuity call such two points of the retina corresponding points. And where the object is seen double, we shall call the points of the retina on which the pictures are formed, points that do not correspond. Now in this first phenomenon it is evident that the two centres of the retina are corresponding points. 2. Supposing the same things as in the last phenomenon, other objects at the same distance from the eye as that to which their axes are directed do also appear single. Thus, if I direct my eyes to a candle placed at the distance of 10 feet, and while I look at this candle, another stands at the same distance from my eyes within the field of vision, I can, while I look at the first candle, attend to the appearance which the second makes to the eye, and I find that in this case it always appears single. It is here to be observed that the pictures of the second candle do not fall upon the centre of the retina, but they both fall upon the same side of the centres, that is, both to the right or both to the left, and both are at the same distance from its centres. This might be easily demonstrated from the principles of optics. Hence it appears that in this second phenomenon of single vision, the corresponding points are points of the two retinae, which are similarly situate with respect to the two centres, being both upon the same side of the centre, and at the same distance from it. It appears likewise from this phenomenon that every point in one retina corresponds with that which is similarly situate in the other. 3. Supposing still the same things, objects which are much nearer to the eyes, or much more distant from them, than that to which the two eyes are directed, appear double. Thus, if the candle is placed at the distance of 10 feet, and I hold my finger at arm's length between my eyes and the candle, when I look at the candle I see my finger double, and when I look at my finger I see the candle double, and the same thing happens with regard to all other objects at like distances, which falls within the sphere of vision. In this phenomenon it is evident to those who understand the principles of optics that the pictures of the objects, which are seen double, do not fall upon points of the retinae which are similarly situate, but that the pictures of the objects seen single do fall upon points similarly situate. Whence we infer that as the points of the two retinae, which are similarly situate with regard to the centres, do correspond, so those which are dissimilarly situate do not correspond. 4. It is to be observed that although in such cases as are mentioned, in the last phenomenon, we have been accustomed from infancy to see objects double which we know to be single, yet custom and experience of the unity of the object never take away this appearance of duplicity. 5. It may, however, be remarked that the custom of attending to visible appearances has a considerable effect, and makes the phenomenon of double vision to be more or less observed and remembered. Thus you may find a man that can say with good conscience that he never saw things double all his life. Yet this very man, put in the situation above mentioned, with his finger between him and the candle, and desired to attend to the appearance of the object which he does not look at, will upon the first trial see the candle double when he looks at his finger, and his finger double when he looks at the candle. Does he now see otherwise than he saw before? No, surely, but he now attends to what he never attended to before. The same double appearance of an object hath been 1,000 times presented to his eye before now, but he did not attend to it, and so it is as little an object of his reflection and memory as if it had never happened. When we look at an object, the circumjacent objects may be seen at the same time, although more obscurely and indistinctly, for the eye hath a considerable field of vision which it takes in at once. But we attend only to the object we look at. The other objects which fall within the field of vision are not attended to, and therefore are as if they were not seen. If any of them draws out attention, it naturally draws the eyes at the same time, for in the common course of life the eyes always follow the attention. Or if at any time in a reverie they are separated from it, we hardly at that time see what is directly before us. Hence we may see the reason why the man we are speaking of thinks that he never before saw an object double. When he looks at any object he sees it single, and takes no notice of the other visible objects at the time, whether they appear single or double. If any of them draws his attention, it draws his eyes at the same time, and as soon as the eyes are turned towards it, it appears single. But in order to see things double, at least in order to have any reflection or remembrance that he did so, it is necessary that he should look at one object, and at the same time attend to the faint appearance of other objects, which are within the same field of vision. This is a practice which perhaps he never used, nor attempted, and therefore he does not recollect that ever he saw an object double. But when he is put upon giving his attention, he immediately sees objects double in the same manner, and with the very same circumstances, as they who have been accustomed, for the greatest part of their lives, to give this attention. There are many phenomena of a similar nature which show that the mind may not attend to, and thereby, in some sort, not perceive, objects that strike the senses. I had occasion to mention several instances of this in the second chapter, and I have been assured by persons of the best skill in music, that in hearing a tune upon the harpsichord, when they give attention to the treble, they do not hear the bass, and when they attend to the bass, they do not perceive the air of the treble. Some persons are so near-sighted that in reading they hold the book to one eye, while the other is directed to other objects. Such persons acquire the habit of attending, in this case, to the objects of one eye, while they give no attention to those of the other. 6. It is observable that in all cases wherein we see an object double, the two appearances have a certain position with regard to one another, and a certain apparent angular distance. This apparent distance is greater or less in different circumstances, but in the same circumstances it is always the same, not only to the same but to different persons. Thus in the experiment above mentioned, if 20 different persons, who see perfectly with both eyes, shall place their finger and the candle at the distances above expressed, and hold their heads upright, looking at the finger they will see 2 candles, one on the right, another on the left. That which is seen on the right is seen by the right eye, and that which is seen on the left by the left eye, and they will see them at the same apparent distance from each other. If again they look at the candle they will see 2 fingers, one on the right and the other on the left, and all will see them at the same apparent distance, the finger towards the left being seen by the right eye, and the other by the left. If the head is laid horizontally to one side, other circumstances remaining the same, one appearance of the object seen double will be directly above the other. In a word, vary the circumstances as you please, and the appearances are varied to all the spectators in one and the same manner. 7. Having made many experiments in order to ascertain the apparent distance of the two appearances of an object seen double, I have found that in all cases this apparent distance is proportioned to the distance between the point of the retina where the picture is made in one eye, and the point which is situated similarly to that on which the picture is made on the other eye, so that as the apparent distance of two objects seen with one eye is proportioned to the arch of the retina which lies between their pictures. In like manner, when an object is seen double with the two eyes, the apparent distance of the two appearances is proportioned to the arc of either retina, which lies between the picture in that retina and the point corresponding to that of the picture in the other retina. 8. As in certain circumstances we invariably see one object appear double, so in others we as invariably see two objects unite into one, and in appearance lose their duplicity. This is evident in the appearance of the binocular telescope, and the same thing happens when any two similar tubes are applied to the two eyes in parallel direction, for in this case we see only one tube, and if two shillings are placed at the extremities of the two tubes, one exactly in the axis of one eye, and the other in the axis of the other eye, we shall see but one shilling. If two pieces of coin, or other bodies of different colour and of different figure, be properly placed in the two axes of the eye, and at the extremities of the tubes, we shall see both bodies in one and the same place, each as it were spread over the other without hiding it, and the colour will be that which is compounded of the two colours. 9. From these phenomena, and from all the trials I have been able to make, it appears evidently that in perfect human eyes the centres of the two retinae correspond and harmonize with each other, and that every other point in one retina doth correspond and harmonize with the point which is similarly situate in the other, in such manner that pictures falling on the corresponding points of the two retinae shew only one object, even when there are really two, and pictures falling upon other points of the retinae which do not correspond show us two visible appearances, although there be but one object. So that pictures upon corresponding points of the two retinae present the same appearance to the mind as if they had both fallen upon the same point of one retina, and pictures upon points of the two retinae which do not correspond present to the mind the same apparent distance and position of two objects, as if one of those pictures was carried to the point corresponding to it in the other retina. This relation and sympathy between corresponding points of the two retinae I do not advance as an hypothesis, but as a general fact or phenomenon of vision. All the phenomena before mentioned of single or double vision lead to it, and are necessary consequences of it. It holds true invariably in all perfect human eyes, as far as I am able to collect from innumerable trials of various kinds made upon my own eyes, and many made by others at my desire. Many of the hypotheses that have been contrived to resolve the phenomena of single and double vision suppose this general fact, while their authors were not aware of it. Sir Isaac Newton, who was too judicious a philosopher and too accurate an observer to have offered even a conjecture which did not tally with the facts that had fallen under his observation, proposes a query with respect to the cause of it. Optics, query 15. The judicious Dr. Smith, in his Optics 1:137, hath confirmed the truth of this general phenomenon from his own experience, not only as to the apparent unity of objects, whose pictures fall upon the corresponding points of the retinae, but also as to the apparent distance of the two appearances of the same object when seen double. This general phenomenon appears therefore to be founded upon a very full induction, which is all the evidence we can have for a fact of this nature. Before we make an end of this subject, it will be proper to inquire first, whether those animals whose eyes have an adverse position on their heads, and look contrary ways, have such corresponding points in their retinae. Secondly, what is the position of the corresponding points in imperfect human eyes, I mean in those that squint; and in the last place, whether this harmony of the corresponding points in the retinae be natural and original, or the effect of custom; and if it is original, whether it can be accounted for by any of the laws of nature already discovered, or whether it is itself to be looked upon as a law of nature and a part of the human constitution. End of Chapter 6, Part 3. Recording by Stephen Reynolds, Durham, Connecticut.